Hello, I'm Mary, and this is my dad. Today, we will be building a mechanical ventilation system, or rather, a prototype of a mechanical ventilation system to aid patients infected with the coronavirus to be able to breathe. The features of this project include a fully automated operation from the system, work from the power grid and off-grid, simple assembly by your family members, and simple operation by your family members. The assembly of this system includes three main components: the air compressor, the controller, and the CPR mask. These subcomponents are split into two categories. Categories include the mechanical parts, which will be covered by my dad, and the electrical parts that will be covered by me.
So, mechanical parts. Ventilation system is based on three main mechanical components, which is air intake, air control, and air output or air consumption. So air intake. In our case, for air intake, we're gonna use the air compressor, and it can be gas-powered air compressor for off-grid operation, or electrical powered air compressor for grid-tie system. The compressed air is going to be connected to this standard connection. This standard connection goes via the T connected to the regular sprinkler valve with the electromagnetic valve, and then output via the hose is going to be connected to the CPR mask. For the hose, we're gonna use standard drain hose that we bought at Lowe's, and for the air consumption, we're gonna use regular CPR mask, and the CPR mask has air input, it has optional oxygen input, it has protection valve, and it has mask. This box we're gonna use to store all the electronics and mechanical parts, and this box is just repurposed from previous project. So instead of this faceplate, we're gonna use different one. On this different faceplate, we're gonna use power switch, screen to display the breathe rate, and the controller for the breathe rate. Within the box, here we're gonna drill the hole for the air intake, drill hole on the side for air output, and for the 12-volt power input. That concludes the mechanical part.
First, we have our power supply, a standard 12 volts, and a power connector to connect it to a simple on and off switch. The electromagnetic relay controls the electrical input. The electrical sprinkler valve. It's a sprinkler valve in this case, but it could be any valve. To control the system, the entire mechanical ventilation system, we are using an Arduino Espora with a TFT screen and with a slider, which is important for us because this slider can be used to control the breathing rate of the person. To power the Arduino Espora, we are using a standard micro USB cable and it is powered from a 12-volt supply, but to convert it to an Arduino power supply, we are using this DC to DC converter that inputs 12 volts and outputs 5 volts. This concludes the electrical components for this project.
So we're gonna split our work, and I'm going to do all the mechanical preparation, and when we are ready, then we're gonna assemble the system, and you're gonna do the programming, and we're gonna check how the system works. And I'll bring the air compressor so that we have the air input to check how the system actually delivers the air to the mask. And then also I will bring the oxygen concentrator that we have in-house.
The prototype of the mechanical ventilation system is now finished, and it works as planned. The mechanical parts my dad will describe, and the electrical parts I will describe. And then we will show you the system in operation. Dad, may you please describe the mechanical parts?
Sure. So like it was discussed, we're gonna have air input, air output, controller, external power, 12 volts. So let me just disconnect and bring in slightly closer. So we have a box, and we were planning to make a hole in this box for air input. We're gonna put the label here, and this is the air input. Then we have air output, and then we have 12 volt power connector. We're gonna put the label here as well. Mechanically, we have faceplate. In this faceplate, we have switch and screen with the control. Mary will describe the electrical part, but with the mechanical parts, that's it. Everything is hooked up in working condition and it's already tested. So let me connect back in, and then air back in, and with the mechanical part, it's done. Your turn, Mark.
Yes.
Okay. So can you switch it on and show the logic behind?
The power switch turns the machine on, as you can see. Then the screen turns on to display the information about the breathing rate currently. As you can see, right now the breathing rate is 11 beats per minute. But if we use the slider, we can either increase the breathing rate for a higher rate, for a quicker rate, to 15 beats per minute, or we can decrease the speed to 8 beats per minute. The scope of these breathing rates is safe for human beings and will not harm them in any way.
I say this is the prototype, and the disadvantage that we noticed is the initial air pressure is too high, and it sounds like a space blaster.
Intergalactic monster.
Yeah, like a space blaster.
Yeah.
Hello again. Last Sunday we built a mechanical ventilation system. This Sunday I would like to explain to you the functionality of the controller. The controller controls the inhale and exhale cycle by switching the relay on and off. The screen displays information about the breathing cycle, and the slider adjusts the breathing cycle from a minimum of 7 breaths per minute to a maximum of 15 breaths per minute with an original value of 10 breaths per minute. The red LED on the right changes its intensity as the slider deviates from its original value of 10 breaths per minute, as you can see right here. Finally, pin 11 of the controller connects the controller to the relay. The source code is self-explanatory. It is posted on GitHub, and you can see it in the description below.
Hi, my name is Mary, and this is my dad.